let's look at this last example, sketching a lemniscate. Sketch the graph of r squared equals 9 sine of 2 theta. So these look a little different. There's an r squared here. And so we could kind of take a look at the pictures to help us out. So r squared equals 9 sine of 2 theta. So sine is going to be symmetric here. So this is kind of what our graph is going to look like. But we're just going to plug in points to help us out. Now the type of curve is a lemniscate or lemniscate. It's going to be symmetric, or the symmetry is with respect to the pole. Again, that just helps you in sketching it. It's not something that you have to really talk about or write down like in the homework. It's not going to ask for that. It's just going to show you the pictures. So the maximum value, what is going to be the maximum value here? So we're looking at r squared equals 9 sine of 2 theta. So notice what's going to happen is that we're going to have to take the square root, and when we take the square root, we're going to get a plus or minus 9 sine of 2 theta. Now this is going to be the maximum value when sine of 2 theta equals 1. So we're looking at plus or minus 9 times 1, or we're looking at plus or minus 3. Now we're only looking at the absolute value, so we know that it's going to be 3. Now let's find out when that happens. Now because this is a square root, you have to be careful, and so we only can choose the values that are going to be positive in there. So just kind of keep that in mind, that we can't take the square root of a negative number, and so, just be mindful of the values that you're choosing. So let's find out when sine of 2 theta equals 1. And so 2 theta equals 1 at pi over 2. Now we can't choose, for example, 3 pi over 2, because remember at that point it is negative 1, and we can't have a negative 1. So we know there's a little restriction there. So we know that, we can't pick that. So what we're looking at is when theta is pi over 4, we're going to have a maximum value here. Now let's find the 0 of r. And so that's when sine of 2 theta equals 0. So when does sine of 2 theta equal 0? Sine of 2 theta equals 0 when it is at 0 and at pi. Then we divide by 2 here. We know that it's going to be 0 at 0 and pi over 2. So let's plug in some values here. Let's plug in 0 first of all, and we know we're going to get a 0 at that point, but let's go ahead and do it. So this is a square root, plus or minus the square root of 9 sine of 2 times 0. And then, so that's going to be 0, and we know this is 0, so we start here. Now let's choose pi over 4. So we have 9 plus or minus 9 times sine of 2 times pi over 4. So we're going to be looking at plus or minus 9. That's going to be just pi over 2, sine of pi over 2. And that sine of pi over 2 we know is 1. So plus or minus the square root of 9. And we had already mentioned earlier, we knew that was going to be our maximum value of 3, and it's plus or minus 3. So at pi over 4, we have a positive 3, which is here. And then we also have a negative 3, which is down on the other side here. Now let's take a look at another value. Let's just choose pi over 6. So plus or minus the square root of 9 times sine of 2 times pi over 6. We're looking at plus or minus 9 of pi over 3, sine of pi over 3. So that's going to be plus or minus the square root of 9 times root 3 over 2. Then if you plug that into your calculator, you're going to find that's approximately plus or minus 2.8 at pi over 6. So that's going to be here, plus or minus 2.8. Maybe it should be a little closer to the 3 here, over here. And then same thing on this side here. So if we go in order, I know I didn't do it in order. So 0, then pi over 6, then pi over 4. So it starts at 0, then pi over 6, then pi over 4. Then we're going to know that's going to reflect here at pi over 3. Then it's going to cross through the 0. And then another point down here. And then so here is the lemniscate. So go ahead and try this next example. R squared equals 4 cosine of 2 theta. So here is the graph. So it's symmetric with respect to the polar axis now. The max value is 2, so in this case I went ahead and I scaled it. So this is 1 and this is 2 here. I just wanted a bigger graph. And so, always keep that in mind when you find the maximum value, if it's possible to scale it a little differently. And so note that we have to be careful of what values we plug in here. We know that the 0 of r is going to be at pi over 4, and we know that the max value is 2, and that helps us out more with the graph. I plugged in 0, then I plugged in pi over 6. At pi over 6, I got plus or minus 1.86, so somewhere over here. At pi over 4, I got a 0, and then I know it's just going to reflect, right? So I just kind of finished some dots here of what's going to happen, and then I finished the curve.